Okay, welcome once again to Brainwave Academy. Today we are going to be talking about a very fantastic and interesting topic. This topic has to do with partial fraction, right? How can you solve partial fraction? Now, partial fraction is a very simple uh, topic, but let's discuss it in details today. For instance, if you're giving a fraction of the form 2, 2 upon x, x minus 3, and you are asked to add this to another expression, say 1 all over x. Now, this expression technically becomes very easy to do. How do we mean? Now, technically, all you're expected to do is to look for the lowest common uh, multiple over here. In this case, all you're going to have is uh, just to look for the LCM and then you multiply. For instance, if I have 2 over x plus 2 plus x over x squared, now we can just have the LCM, which we can just multiply these two together, x squared into x plus 2. Then when this goes into this particular LCM, you'll be left with x squared multiplied by 2 is 2x squared, right? Then similarly, we have this addition over here, right? So when you have x squared into this, we'll have x plus 2. Multiply it by x, we'll have x into x plus 2. Good. This is straightforward. But assuming you are given the function of this form, 3x plus 5, this is upon x minus 3, right? Then you have 2x plus 1, right? Clearly, this is equal to, this is the same thing as 2 over x minus 3 minus 1 all over 2x plus 1. Excuse me. Now I have succeeded in splitting this into two fractions. That is what we call partial fraction. So how do we achieve this? This is what you're going to be learning in this video today. So just take a cup of water and then watch while we demystify this particular example. Now, at the end of this video, you're going to learn how to do that for every other particular uh, uh, fraction that you're giving. You're going to learn how to do that, right? You're going to get the general formula. You're going to get the general formula. General formula. Good. You're going to get for all the expression, if it is repeating, if the factors are repeating the denominator, you're going to get all that figured out in this video. But first of all, let's look at how we arrive at this. Now, in this case, you can see that you consider the denominator of this. If it is of this form, definitely you should know that your expression 3x plus 5 upon, right, 3x plus 5 upon, you have x minus 3 right? 2x plus 1 is definitely going to be a particular integer which we don't know, or a fraction or a number, then x minus 3, right? Then plus another particular uh, number which we don't know upon 2x plus 1. Now just stick with me. You understand all the basics, but for now, let's get how we arrive at this. Good. So basically, I'm supposed to clear the fraction. I want to clear the fraction. Now let me clear this fraction. It's very simple. I'll multiply all through by this denominator. I'll multiply here by the denominator. We have x minus 3, 2x plus 1. And since I multiplied left-hand side, this left-hand side, I have to do that to the right-hand side also, right? So I'll multiply everything here, right? Everything here. So by so doing, I know that this term is going to cancel out. So I'm left with 3x plus 5. But in this case, I'm multiplying everything, right? I'm multiplying everything here by this particular term here, x minus 3, then 2x plus 1. Good. So I'll have here x minus 3, 2x plus 1, multiplying a plus this is all over x minus 3, right? Which is here. Excuse me. So we have the next element here, x minus 3, because this is going to multiply this also. 2x plus 1. We have b. This is all over 2x plus 1. Fantastic. Fantastic. I know this and this are going out. Similarly, this and this are going out. So we'll have 3x plus 5 is equal to 2x plus 1. We have a, so we'll have plus x minus 3b. Good. So there are many ways to solve this. If you look at this, it's linear. So one way is to set the coefficient of one of the variable to 0. So if we here in this equation, right, if we set s to be equal to 3, then definitely we're going to get 3 into 3 plus 5 is equal to 2 into 3 plus 1, right? Multiply by a, then plus we have 3 minus 3, then b. So technically, we are intuitively trying to eliminate 3 because 3 minus 3 is 0. So b here will be gone. So this implies that what do we have now? We have 3 multiplied by 3 should give us 9. That's 3 multiplied by 3 plus 5. So have plus 5 should be equal to 2 multiplied by 3. This should give us 6. So we'll have this is 6 plus 1. Then we have a. Fantastic. So here, therefore, we'll have this should give us 14, right? Is equal to 7a. So by the time we divide both sides, then we discover that a is equal to 2. But divide both sides by 7, right? So we discover that a is equal to 2. Good. Similarly, if we set in this particular equation, if we set x to be equal to 1 over 2, right? Negative 1 over 2, I think a will be gone here. So we'll have 3 into negative 1 over 2 plus 5 should be equal to 2 into negative 1 over 2, then plus 1 of a. Then this will be plus into -1 all over 2 minus 3b. 2 multiplied by -1 is -2. -2 divided by 2 is -1, plus 1 is 0, right? Fantastic. So here, what we're going to get what here? Let's do it over here. We're going to get 3 all over 2 negative plus 5. Then we'll have, what would that be for B? For B, we have -1 all over 2 minus 3. And then all these are the coefficients of B, right? So that's fantastic. So here, the LCM here is 1. The LCM here is also 1. So, so let's continue over here. So that means we have 2 into this is -3 plus 10, right? All over 2. Then here we're going to have 2 is the LCM, so we'll have all over 2. All over 2. Then we have -1, -1, -6, right? So we're supposed to have -1, -6. Because 1 into 2 is 2, 2 multiplied by 3 is 6. Then all these are the coefficients of B, right? So technically, you're going to be getting above here, this should be 7. Therefore, we have 7 all over 2 is equal to here -7 all over 2, then B. So if we divide both sides, it implies that if we divide here, 7 can go in, 7 here, everything here. So we discover that our B here is equal to -1, right? Because technically, if we divide both sides by 7 over 2, 7 over 2, there's going to cancel out. So here is -1. So our B is -1. So that's why I will come back to this particular expression. For my A we got 2. Then I'll substitute 2 here for A. While for B we got -1. You see, that's how we got this particular expression. So it's as simple as that. It's as simple as that. Now, let's see if we can take a smaller example again so that we continue. We have this 3x upon x plus 1. Then we have x plus 2, right? So this is equal to a constant. You can put any variable all over x plus 1, right? Then you have plus another constant upon an x plus 2, right? So we're going to do the same thing again. So we're going to multiply the steps, multiply the first expression, right? We'll multiply everywhere by this expression. Good. So we're going to do that for A. So have x plus 1. I think it's, oh, this is negative. This is negative. This is negative. Let me take this out. Good. This is negative. Good, 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 good. Fantastic. So have this is supposed to be x minus 1. Good. So x minus 1. X minus 1. Then we'll also have, I can take out this guy. This is also supposed to be x minus 1. Good. So this is negative, right? That's a mistake. Pardon. So we'll have x minus 1 multiplied by x plus 2, right? So we'll have A plus the same thing, x plus 2, then we'll have B. This is upon x plus 2, which I know they're going to cancel out. So we'll have x minus 1. This also is going to cancel out. This go, this cancel out. So I left it 3x is equal to x plus 2. And then all these are the coefficient of A, plus we have x minus 1. All these are the coefficient of B. B. Fantastic, fantastic, fantastic. So what can you see? So we can also set, let's say, set x to be equal to minus 2 over here. So you have 3 into minus 2. I want to eliminate A, that's why I did that. So I have minus 2 plus 2 of A plus minus 2 minus 1 of B. So I have minus 6 is equal to A is gone, is equal to minus 3B, right? So if I divide both sides by minus 3, so I have divide both sides by minus 3 upon minus 3. Then I'm going to get, technically my B is going to be what? 2. Good. So secondly, if we set for here now, we can set x got to minus, no, positive 1. Rather, x should just be 1 over here, and B will be gone. So I have 3 into 1 is equal to 1 plus 2 of A, then plus 1 minus 1 of B. And B is gone, so I have 3 is equal to 3A. So if I divide both sides by 3, my A automatically is going to be 1. Fantastic. So all I need to do, that means this expression here, over here, should be the same thing as A is 1 upon x minus 1. Then we'll have plus B is 2 upon x plus 2. So clearly you can see that technically it's very simple, especially when the denominator are just two particular terms, right? Multiplying together, the two terms have the degree of x to be the same. So if you have that, then you can do this particular method to be able to get this particular way. Good. Now, it's very clear that all these steps are just for this particular type of partial fraction, right? So I'm going to be giving you all the details of these particular steps that we are going to be solving. So in general, what will happen if you have if we are given an expression of this form, let's say we have 3x plus 1, then upon we have x minus 1 squared, then we have x plus 2, right? So how can we express this? Now, this kind of expression where the denominator has a repeated factor, you can see that this factor is repeated. This kind of expression whereby it has a repeated factor, then therefore, you are going to have 3 terms. This for the first one, right? For the first factor, x minus 1, good. Then we're going to have the second constant. Now, for the second factor with the power of 2, so we'll have x minus 1 to the power of 2. Then we're going to have the third constant. Now, the third constant is going to be x plus 2, right? So the steps also, we continue to multiply both sides by this. We take out the element that will remain, then we factor out with 0. Good. Then let's see if we have another case. Now, if the denominator has a quadratic term, for example, we're going to solve this before the end of this video. So this is if it has repeated factors, right? if they are repeated factors. Good. But now if it has a quadratic uh, expression in the denominator, if quadratic expression in the denominator, there is a quadratic term. For example, let's find an example. If we have 5x, then we have a quadratic term, x squared maybe plus x plus 1, right? This is squared. Then we have x minus 2. If there's a quadratic term, then it automatically becomes x plus b, right? This has a quadratic term. So the power here is going to be reduced by 1. Then we'll have x squared plus x plus 1, then plus c to accommodate this other guy upon x minus 2. Good. Now, is there any other particular expression that we are going to be considering? Is there any other one I'm going to be showing you at the end of this video in the generalized form, so that as they keep on repeating, you will not have any issue at all? Good. So right now, let me see how we can solve this particular expression, right? So I'm going to use this particular side to do that. Now, it's very simple. Let's see how we can do that. Let me put this over here and deal with the first one. So for that first one, we're going to do it similarly like we did to the other ones. We're going to multiply to both sides this factor here, right? So we're multiplying it by what? 3x plus 1. Then we are going to have this particular one also, x minus 1 squared, x plus 2. So we're going to be doing that to this particular side also, minus 1. We have squared, and x plus 2. Then this is a upon x minus 1. So we're going to have in the second one now x minus 1 all squared, x plus 2. This is b. Then plus the c part. Then the c part, we have x minus 1 squared, x plus 2, then multiply by c. Then this is for the other guy, x plus 2, right? So this guy is going to take out one term. These particular terms here are going to cancel out, which we know already. This term here is going to cancel out this term. This term also is going to cancel out this term. So what we are left with 3x plus 1, which is over here, right? Then is here 1x, then x plus 2. This is a. What is left here? We have plus x plus 2 of b. Then we'll have plus x minus 1 all squared of c. Good. That is what we are going to be having here. So we see that it's very simple, right? So here, over here, if we let x is equal to 1 over here, we're going to have 3 into 1 plus 1 is equal to, we're going to be having 1 minus 1, x plus 2. I think a is gone because of this factor 0 here, so a is gone. So here we're going to be left with 1 plus 2 of b plus, similarly, 1 minus 1 squared, c will be gone also, right? 1 minus 1 over there, I think c will be gone. So we have 3 multiplied by 1 is 3 plus 1, this is 4, is equal to, what do we have? 3b, 1 plus 3, this is 3b, right? 3b. So therefore, our B, if we divide both sides by 3, our B is going to be 4 over what? Over 3. Fantastic, fantastic. So here, since we have B, if I say this is minus 2, I think we're going to get C. So let's put, so let's here, X is equal to -2. If I put -2 here, I'm going to get 0, 0. I'll be left with C. So I have 3 into -2 plus 1 is going to be -2 minus 1 into -2 plus 2. A, which I know is going to be gone because of 2 minus 2 is 0. So here I have plus -2 plus 2 is also going to be 0. Yes. So I have plus, so here I have -2 minus 1 all squared C. So here I'm going to be having -6, right? -6 plus 1, which is going to give me -5. While over here, I'm going to be having -3 all squared. So -3 all squared is going to be giving me 9, positive 9. If I have -3 times -3, right? I'm going to have 9C. So therefore, if I divide both sides by 9, I divide both sides by 9, so my C will be equal to -5 upon 9. Fantastic, fantastic. So how am I going to get the value for A right now? So I'm going to be introducing another technique called comparing the powers of the coefficients. You call it equating coefficient. So let's expand this particular expression and then factor out the common factors of A. Let's expand this expression over here, right? So by so doing, we have 3x plus 1. The A guy is going to give me x multiplied by x is going to be x squared, then x multiplied by 2, this is going to give me plus 2x. I'm done with x, then -1 multiplied by x minus x, then -1 multiplied by 2 is -1. So we have 2x minus x. This is going to give me x. So here, I'm going to have x squared plus x minus 1 of A. Fantastic. So similarly, I'm going to be doing this for B. So for B, there is nothing to be done. This is B. Then lastly, for C, this is the same thing as saying you have x. So let's do over here, x minus x all squared. So you're going to have x squared, x multiplied by 1 minus x multiplied by minus x, another 1 multiplied by x minus x, then plus 1. So I have x squared minus 2x plus 1. Then we'll have C. You can cross-check this. I think this is just x minus 1 into x minus 1. So if I'm not mistaken, I'm going to have this and this is x squared, this and this minus x, this and this minus x, this and this plus 1. So we are correct. So we have 3x plus 1 is equal to, we can multiply. We have x squared plus ax minus a. Here we're going to have plus bx plus 2b. While here we're going to have x squared c or cx squared, this plus. So we have minus 2cx then plus c. Now collect the terms together using the powers of x. So we'll have a here, have x also plus c here. They are all having x squared, right? So let's collect the ones that have x together. We'll have a here, have x. We have b, x. So here we have minus 2c, right? All these are coefficient of x. Then we'll have the last terms there is just b. So we'll have just minus a plus 2b, then plus c. right? But we are interested in just this particular term. We're going to equate it with the powers here. So here is the same thing as saying you have 0x squared, right? Because there's nothing like x squared in this side. So we equate them together. So this, we're going to have 0 is equal to a plus c. Similarly, if you want to get the coefficients here, you use 3 is going to be what? 3 is going to be equal to a plus b minus 2c. You can cross-check if we are accurate. Then for the constant term, this will be equal to all this. But we're interested in this guy, a plus c. We already know c. C is over here, right? So if I take this to the other side, that means my a is actually negative c. But we know what is c. C is negative minus 5 over 9. So we have minus into minus 5 upon 9. So automatically our A is just 5 upon 9. Fast, fantastic. So we just go there and replace here over here by A here is 5 upon 9. B is what 4 over 3. Then we'll have our C is minus 5 upon 9. So fantastic. I can rewrite this as 5 upon 9 over x minus 1. This can be written as 4 over 3 into x minus 1 all squared. This is negative, so we have negative 5 upon x plus 2. How cool is this? How cool is this? Fantastic, right? This is fantastic. So automatically we have gotten this. So to get this is pretty cool and simple. It's straightforward, and you will use the concept of equating the coefficient. All you need to do automatically is to multiply this by this term, multiply individually by this term, then you expand everything, and you are good to go. Now, let's see if we can do it at the end of this video. But for now, let me try and introduce you to the general knowledge, the general idea. So basically, what is the general idea of this particular partial fraction? The steps you're supposed to take, then you're going to be taking the clear terms and considering the powers of the denominator. So I'm going to be listing out some of the formulas that is going to guide you, right? This is going to guide you, and you are not going to be having so many challenges when it comes to this particular partial fraction. Now, the first and foremost is a very wonderful technique. This technique is if you have, if the denominator is a linear factor, right? And occurs and it is not repeating. For instance, you have the general form, you have it is a linear factor, you have it linear in this form. Now, once it is linear, right? Let's say that is first of all, you have to consider it. This is the numerator, right? And then this is the denominator. Look at it very critically. If the denominator has just linear factor, when we talk about linear factor, it has a constant, maybe just x, and plus another constant b. This is linear, right? This is linear. If it has a linear factor and it is not repeating, it does not repeat itself, then you are going to be taking this, right? Just like our first example. Now, if the denominator, that's number one, number two, now if the denominator, right, is repeating, it is a linear factor, it is a linear factor, but is repeating, is repeated. It reoccur, which means you can have ax plus b, you can have 1, 2, 3, 4, 5, up to n, then it's very simple, right? It's very simple. So the first one is going to be a1 upon a b. This is raised to power 1. We're going to be adding it to a2 upon ax plus b. This is going to be the second one, right? Plus, if this is more than 2, assuming it is 3, then you're going to have a3. If your n is 3, upon the third one, which is ax plus b raised to power 3, then you are going to be just having them until you get to the last one. The last one now will be an, right? So let's assume this is 10. You're going to have an. Then you're going to have ax plus b, then raised to power n. This is going to be the last term, right? Now, thirdly, if there is a quadratic factor in the term in the denominator. So when you consider the denominator and it has a quadratic term, Now, the general form of a quadratic term is what? You have ax squared plus bx plus c. This is a quadratic term. So once you see this appearing in the denominator, let me just give you, the concept is that you're going to be having the partial fraction of this form, a constant, which you have done an example, plus another constant, then the quadratic guy is going to come below x squared plus bx, then plus c. Now, let's generalize it. Generalize this if it is repeating the denominator. So the fourth one, if the denominator has the quadratic term and it is repeating, that is a quadratic term, that's one, you have noticed that. Then, and also it is repeating as a quadratic term and it is repeating, right? So similarly, just like we have done with the singular term, that's the same thing you're going to do with the terms that are repeating. So in this case, we're going to have a1 of x plus b1. Then all these constants, they are going to be for the initial one, which is ax squared plus bx plus c, of course. Then plus you're going to have, if this the second one, a2 of x plus b2 upon ax squared plus bx plus c. This will now be raised to power 2 until you get to the last term, right? Until you get to the last term. So the last term should look like an of x plus bn, then upon ax squared plus bx plus c. This is going to be the last term, right? So these are the cases you have. Now, all these evaluation of the coefficient is based on the following. If the two polynomials are equal for all values of the variables, then the coefficient have the same degree on both sides. Now, you can always equate the coefficient, which we have done. Equating coefficient is a fantastic idea. For instance, if I say I have p of x squared plus p of x squared, let me take out this term and do it properly. So we have plus q of x plus a is equal to 2x squared minus 3x plus 5, right? So for all x, then we can say that these are equivalent. So if these are equivalent, I can equate the coefficient of x according to their powers. So I can clearly say that p is equal to 2, and then clearly say that q, right, is equal to minus 3, because that's the coefficient of x over here. Then the constant term a is equal to 5. We have established this fact, right? We have established this fact. We have also used this in example, I think 2 or 3, we have used this and also used this. So these are the general types and these are the general forms of polynomial that you can have. So let's try one simpler example before we call it a day in this video. And the example is just you have 7x minus 25, right? Upon you have x minus 3, good, then into x minus 4. Technically, this is the simplest case where we just use this. So this is going to be a constant. You can name it anything, a or b. A upon x minus 3, right? Then you have plus b upon x minus 4. So what's the next step? You multiply everywhere by this guy. So we have x minus 3, x minus 4 upon x minus 3, x minus 4, multiplying 7x minus 25. Then we multiply here also x minus 3, right? X minus 4, a plus, we now have x minus 3, x minus 4, b. Fantastic. So we have, this is what we have. You can always pause the video to watch where you are getting this mixed up. So you have 7x minus 25. This should be equal to x minus 4. This is a plus minus, we have x minus 3, then b. Clearly, if we set here to be 4, a will be gone. So that's the idea. So we have 7 into 4 minus 25 should give us 4 minus 4a. This is gone. So we have 4 minus 3 of b. So here I'm going to get hopefully 28. So we have 28 minus 25 is going to be, this is gone, 4 minus 1, this is going to be b. So therefore, our b here is what? Our b over here is, I think, 3. 28. 28 minus 25 is, I think, is 3, right? Now, let's do for b. Now, it's very crucial. You can see here, if we now set, here we make x to be 4. Here, let's set x to be equal to 3. So we'll have 7 into 3 minus 25 should give us 3 minus 4 of a, then plus you have 3 minus 3 of b. You can see that b is gone. So this we have 21 minus 25 is going to be what? Minus a, because this is minus 1. Then minus 21 minus 25. This should give us minus 4, right? Minus 4 is equal to minus a. So I can divide both sides here by minus 1, right? So I have my a to be equal to, I think, 4. So automatically, that we have tried to split this partial fraction into 4 over x minus 3, then plus b is what? What's b? B, I think, is 3. So this b is 3 upon x minus 4. Good. So in the next video, we are going to be getting more example. We are going to be getting more example, and then we're going to be solving that last equation that we have. So you can skip to any example you want to watch at any particular time. Maybe check the timestamp, you watch this video over here or this one over here. You can watch either this or this for you to understand the simple algebra and then to get the solution to the next video. So you can do that. Check the link in the description below to see more examples. Thank you for watching, and then see you next time.